At Google, the job of a site reliability engineer involves building tools to automate infrastructure operations. If a server crashes, there is automation in place to create a new server. If a service starts to receive a high load of traffic, there is automation in place to scale up the instances of that service. In order to create an automated response to one of these infrastructure problems, like a server crashing or perhaps a voice assistant responding in an incorrect way, you need to have insights into that infrastructure. So every service needs tools around monitoring and alerting and debugging and distributed tracing. And one benefit of working at a large company like Google, for example, is that an engineer building a new product gets this kind of tooling by default. So if you start a Maps product at Google, for example, you are going to get monitoring and alerting and debugging and distributed tracing right out of the box just by virtue of setting up that service within Google. In contrast, if I'm hacking at home by myself on some random project, I have to set up all kinds of tools to help me diagnose and resolve problems. I have to set up my own little debugging system and my monitoring system. And setting up all this tooling can take time and it can require expertise. StackDriver is a set of tools and instrumentation that allows developers to monitor and debug and inspect infrastructure. StackDriver is a tool for engineers that's based on the internal observability tools that were built for Google. Mark Carter is a group product manager at Google, and he joins the show to discuss site reliability engineering and the creation of the StackDriver product. Before we get started, I want to mention I'm hiring for a new company that I'm starting, and I can't talk about the product quite yet, but I'm very excited about it, and I'm looking for an engineer in the Bay Area to join me. I'm looking for somebody with significant experience in React.js and either AWS or Google Cloud. You can email me at jeff@softwareengineeringdaily.com, or you can check out the job posting at softwareengineeringdaily.com/jobs if you're interested. You listen to this podcast to raise your skills. You're getting exposure to new technologies and becoming a better engineer because of it. Your job should reward you for being a constant learner. And Hired helps you find your dream job. Hired makes finding a new job easy. On Hired, companies request interviews from software engineers with upfront offers of salary and equity, so that you don't waste your time with a company that is not going to value your time. Hired makes finding a job efficient, and they work with more than 6,000 companies, from startups to large public companies. Go to hired.com/sedaily and get $600 free if you find a job through Hired. Normally, you get $300 for finding a job through Hired, but if you use our link, hired.com/sedaily, you get $600, plus you're supporting SE Daily. To get that $600 signing bonus upon finding a job, go to hired.com/sedaily. Hired saves you time, and it helps you find the job of your dreams. It's completely free. And also, if you're not looking for a job, but you know someone who is, you can refer them to Hired and get a $1,337 bonus. You can go to hired.com/sedaily and click Refer a Friend. Thanks to Hired for sponsoring Software Engineering Daily. Mark Carter, you are a group product manager at Google. Welcome to Software Engineering Daily.
Great to be here. Thank you, Jeff.
You work on the StackDriver product, which is a suite of tools that's developed in parallel to some of the tools that have been developed in Google's SRE team, the Site Reliability Engineering team. And we've done some shows about site reliability engineering. Can you describe some of the types of internal tools that were built under the Site Reliability Engineering brand of software engineering at Google?
We tend to think about SRE as what happens when you treat operations the same way you deal with software products. SRE is about optimizing the performance, the reliability, the availability, and providing end-to-end observability and reducing toil. At Google, we've been on a journey for the last 15 to 20 years, and we have managed to build multiple billion user services that are trusted by our customers. Many customers tell me that when they want to know if the internet is up, they go to google.com, and that's the level of availability we inspire for. To take the toil out of the works that our engineers do and provide integrated observability, we built a set of tools in Google that encompasses the range of what a software engineer will need to operate a service. It starts with when a software is deployed at Google, the monitoring, logging, tracing, all the golden signals that are required to evaluate the availability are automatically instrumented as part of the software deployment. The dashboards needed are automatically generated. There are tools to manage incidents if and when something goes wrong. There are tools to automatically manage capacity and automatically scale, and a set of tools that deals with how do you take a service from one instance to billions of instances running across the globe.
So if I stand up a service at Google, maybe it's an internal service that's some piece of middleware, or it's a service like Gmail, or maybe more likely some sort of microservice that falls under the purview of the Gmail product. When I stand up that service, it automatically gets provisioned with a bunch of different pieces of tooling that I'm going to want out of the box, regardless of what my service does. Is that correct?
Exactly, Jeff. We believe that separating the undifferentiated work from the software engineering work, allowing the software engineer to focus on providing value, and automatically integrating things like security, like monitoring, like tracing, like automated scale-up, availability, independent of how the software is built, is the way for us to achieve scale and availability. And as such, as an engineer in Google, all I know is I build my service provides this function, and I say how much do I need to scale and what the properties of my service, and the rest is handled automatically by the system.
It seems like there are some subjective decisions that an engineer can make when they're setting up observability tools, because under some circumstances, maybe I want to do lower level monitoring. Maybe I want to have more verbose log management, or I want to have a specific expiration time for my logs. Maybe I don't want to do log rolling as aggressively with this service, or maybe I want some specific machine learning related observability tooling. What are the kinds of subjective decisions and the kinds of configuration that an engineer might be needing to make when they are setting up that observability tooling?
When a service is first initiated at Google, early in the development of the service, it's part of our SRE practices. The SREs that will operate the service sit down with the owners of the service and ask the key questions, such as what kind of data will your service need? What's the level of availability that you are aiming for, and why? What are the critical user journeys? What kind of signals do you need to collect, and for how long do you need to keep them? What kind of logging would you omit, and who needs access to those logs? In Google, we put privacy and security first. So all data that get omitted by a service is strictly controlled, and one needs to think about should that data be generated to begin with. Once all of those are defined, we create a template for observability for that service that specify all the things that the service need to behave. And that defines things like retention, how long the information is kept, the sensitivity and the information, and provide abilities to dynamically change the verbosity level of the information that is generated.
So you talked about some of these different sets of tools, the things like distributed tracing and logging. Can you outline in a little more detail what sorts of situations some of these observability tools help with, or what are the typical problems that an engineer is going to encounter, and what kinds of observability do they need to solve those problems?
When you get to billions of containers running worldwide, the key challenge is there's no more box that you can sign into and troubleshoot your service. There's no more somewhere that you can do tile -F and just watch the log go by, because, which of the billion boxes would you choose? So what happens is we consolidate around what we call the SRE golden signals, which are things like availability, like traffic, like latency, like saturation. Do I have enough resources to meet the demand that I'm seeing? What is the error rates that we see for the service? When one of those golden signals hits the target SLOs that we defined, and that SLO is defined by what do we want to provide to our customer, the SRE team or the engineering team get called and an incident gets created. At that point, the question becomes, okay, who's experiencing the problem, how big the problem is, and how do I pinpoint where in a highly complex systems that can have thousands of services involved is the problem. And we use a set of tools that we also make available to our cloud customer through StackDriver. And those include 3 tools, which are part of our APM suite. One is distributed tracing, the second one is profiler, and the third one is debugger. Tracing provides the ability to figure out, show me my entire system, show me the flows, show me how the communication goes between them in real time, and show me where the problem is in the entire call chain, and let me go through the entire flow and figure out which component is having the problem. The second one is profiler, which gives you the ability, once you pinpointed where in the chain the problem is, to in real time profile the system and figure out what component within the service is having the problem. And then finally, debugger, which is one of the really magical things in Google, allows you to debug production services in real time without impacting the user, and very quickly add logging without redeploying the service, as well as immediately get the same powerful experience that you get from an IDE in a production environment.
You touched on something there with the fact that you can have a ton of containers under, representing one single service, as opposed to the idea of a single host being responsible for a service. And I remember when I was doing some shows about Prometheus, when Prometheus was the Prometheus project, that infrastructure monitoring project that was modeled after Borgmon. I remember talking to the people who were working on Prometheus, and they were saying that one aspect of Prometheus is that it represented a shift, I think, if I remember them correctly, a shift from host level monitoring to service level monitoring, meaning that instead of focusing on looking at the logs of a specific host, you might look at the aggregated logs for all of the containers, for example, that are symbolic of what that service does. So each of the replicas, for example. Am I recalling that correctly? Is that the idea of service level monitoring versus host level monitoring?
That's a very insightful observation, and you are 100% correct. I think we've been, you and me and the industry in a transition, which is an amazing journey, really, from the point where we have pets, we have the server and we know what it does, to vast level of resourcing across public clouds and our data centers, where you can deploy things and immediately make it available worldwide. And you can have, through things like Kubernetes and Istio, be able to provide functionality where you don't care about one machine, you care about service. And when we transition to those kind of thinking, projects like Prometheus, and Google has been very supportive of Prometheus, one of the key maintainers work here, as well as things like StackDriver, provide you the ability to, instead of saying, what's the health of this machine, go and think about what level of service am I providing to my customer, what's critical for that service, and how is that service doing against what I want my customers to experience.
And so with that service level monitoring specifically, as opposed to host level monitoring, if I notice something that's going wrong with my service, doesn't it become host level response? Like, wouldn't I want to kill one of those containers if I find out, if I'm doing that service level monitoring and I notice there's some kind of anomaly, is my course of action going to be to identify the container that's behaving anonymously and kill it and let a new container start up to replace it and hope that solves the problem? Is that a realistic order of operations?
That's a super interesting question, and I don't know that there's one answer fits all, but I can tell you that in our experience in running very vast production environment, just responding by, okay, this thing is having a problem, let's shoot it and spin up another one, can have disastrous implications because it can create, a chain where things start dying all over the place. And, that's not a place any of us want to be in. We believe in SREs that the better approach would be to ask, okay, what changed? What were the set of events when our golden signal started changing? And in order to address that, we have a very strict way of how do we handle an incident. We have an incident commander, we have a technical lead, we have a communication lead, where it's very clear what decisions are being made and what information is presented to you. And then combining that with a set of continuous integration and delivery tools like Cloud Beyond that we announced last week at Next, allows you the ability to say, at that point when things started going wrong, this version of the software for this component was in the process of being deployed, and they're using the transaction log to say, bring back the previous version of the software, which is a much more targeted solution than just say, let's kill that thing.
You've mentioned this golden signal idea a couple times. Can you talk about that in more detail? What is a golden signal?
Again, golden signals is just our experience of what we found to be most insightful about our services. Customers' mileage may vary, but we think that there's a lot of common sense in them. So I'll go through a bunch of them. The first one is error rate. And error rate relates to a concept we hold here in Google called error budgets, which really says, okay, a certain service, let's take Gmail, for example. Let's say that you're a Gmail user, and one key user journey would be, well, I want to send email. So we declare that out of, let's say, every million requests to the send email API, only 1,000 requests can fail. And we say that's acceptable because, well, there's retry in the Gmail client and most of our customers will never notice. So there's no such thing as a perfect availability, and you should stay away from there. But you need to define a certain acceptable error rate and define an error budget that the team is allowed to experience. So one thing that we track across all our services is what's the acceptable error rate, what's the common error rate, and start to engage our SREs when we're seeing that the error rate is trending towards violating the service level objective. Another example is saturation. We think a lot about the cloud as this unlimited vast resource, but even in the cloud, there's limit to resources. There's things like noisy neighbors that might impact you. So saturation really says, do I have enough resources allocated to that service to be able to service the SLOs that I'm looking for? And if I'm seeing that the stress on the resources allocated is exceeding a certain level that I define as reasonable, then I should stop and reevaluate and reallocate resource. And maybe lastly, really quickly, I will touch on latency, which I personally feel is one of the most important signals, because latency really says how long does it take to achieve the functionality that I wanted. And we all know that, when you open a browser and go somewhere, will only wait a few seconds before you say, oh, this is a really not interesting website, let's go somewhere else. So being able to treasure and being able to track the latency we provide to our customers and immediately alert when we see that the latency is trending towards an SLO violation is one of our key golden signals.
Cloud computing can get expensive. If you're spending too much money on your cloud infrastructure, check out Do It International. Do It International helps startups optimize the costs of their workloads across Google Cloud and AWS so that the startups can spend more time building their new software and less time reducing their cost. Do It International helps clients optimize their costs. And if your cloud bill is over $10,000 per month, you can get a free cost optimization assessment by going to doit-intl.com/sedaily. That's doit-intl.com/sedaily. This assessment will show you how you can save money on your cloud. And Do It International is offering it to our listeners for free. They normally charge $5,000 for this assessment, but Do It International is offering it free to listeners of the show with more than $10,000 in monthly spend. And if you don't know whether or not you're spending $10,000, if your company is that big, there's a good chance you're spending $10,000. So maybe go ask somebody else in the finance department. Do It International is a company that's made up of experts in cloud engineering and optimization. They can help you run your infrastructure more efficiently by helping you use commitments, spot instances, right sizing, and unique purchasing techniques. This to me sounds extremely domain specific, so it makes sense to me from that perspective to hire a team of people who can help you figure out how to implement these techniques. Do It International can help you write more efficient code. They can help you build more efficient infrastructure. They also have their own custom software that they've written, which is a complete cost optimization platform for Google Cloud, and that's available at reoptimize.io as a free service if you want to check out what Do It International is capable of building. Do It International are experts in cloud cost optimization, and if you're spending more than $10,000, you can get a free assessment by going to doit-intl.com/sedaily and see how much money you can save on your cloud deployment. Speaking about latency, there are some types of latency that can be really hard to diagnose. For example, tail latency, where if you take a large sample of response times and you find that at the tails you have some very severe latency cases, and it can be really hard to diagnose why this is happening. And it may be due to something like a noisy neighbor, or there's some hardware specific issue that only happens every 30 minutes. Can you talk about some of these issues that are particularly hard to identify in a cloud environment, and also how, if you wanted to, because you're working on a product like the StackDriver product that we'll get into momentarily, but this product is to give people observability and help them track down some of these errors. How do you build a tool that provides somewhat standardized solutions to something like tail latency that's pretty hard to ascribe general causation to?
That's a tough one. Our approach within Google for years has been standardize the way you instrument your software, and you will be able to consistently identify issues. And internally in Google, we use something we call Census. We have open source that over the last few years, you've seen a lot of software coming out of Google as open source. That is the open version of what we do internally in our production. Open Census is one key example, which is a consistent set of libraries and specification that allows you to very quickly, by including a library in your application when you compile it, to automatically omit trace information and metric information that lets you diagnose such problem in real time. What happens in our production environment when one of those things happen, since Census omits traces as requests happen, and since all of our production environment is instrumented with a profiler and debugger that let us profile and debug in production, you can do such a thing as, say, profile all the instances of my service, and when one of them hits a latency that is above a certain thing, automatically I activate the profiler and give me a profiler analysis of which functions are causing that problem. And if that information is not enough, we can create a breakpoint in our debugger and say, when something hits that function, please create a memory snapshot of what was going on and let me debug that in my free time without impacting the user and figure out what's going wrong there when that wait state is happening. We have been very fortunate in Google Cloud that because of our global distributed resource management, the issue of noisy neighbors almost does not exist in GCP. I would say that in Borg, which is our production environment, we have not invested as much as we invested in our cloud customers, and we have come across many scenarios where noisy neighbors have resulted in cases where we had to identify who is the noisy neighbor and then enforce more strict resource allocation.
So you talked a little bit there about the externalization of services and the open sourcing and externalization of services. So with Borg, the infrastructure management tool that has been active in Google for many years, the Borg system was tightly coupled to how Google does certain things. And so with Borg, Kubernetes provided an open source version of Borg, but it was basically a rewrite, another rewrite of Borg. Was this also the case with because StackDriver is another one of these externalizations of Google infrastructure? Was this another case where kind of the internal tools were a little bit too tightly coupled with how Google does things, the internal assumptions of Google, and there was a lot of rewriting that was necessary? Or were you able to reuse a lot of the internal systems and the internal code from Google's monitoring?
I would say that it was an interesting conversion of bringing stuff from the outside. For example, StackDriver, the monitoring experience started off as an AWS-based software as a service solution that Google acquired 4 years ago. And we have consistently made sure to keep StackDriver hybrid. StackDriver today monitors a hybrid environment, multi-cloud environment, and continuously expanding. So in that fashion, the customer-facing UI experience have come from the outside in. On the other hand, the backend, which is our time series database that stores all the metrics, as well as our logging platform, is the exact same backend system that is used for Google production services. So, we run at Google what I think is probably the largest time series database in the world, with tens and hundreds of petabytes of time series data being consumed at any given time. Our logging platform supports, we have customers that sends in petabytes per day of data and is able to deal with rapid scaling of thousands of percentage. On the other hand, where it comes to integrating with our customers, we made sure to continuously use open source projects. So Google adopted FluentD, which is our logging agent. It's an open source Apache project that Google helps maintain. We adopted Collecti as a monitoring agent, again, an open source Apache project. And we are partnering with most of the leading vendor in the monitoring space around open sensors, which is the externalization of our internal instrumentation as an open source project.
Okay, so StackDriver is a combination of different observability tools into a single tool. So the idea is if people are spinning up infrastructure, they're going to want some observability tools out of the box, much like you get at Google. I used to work at Amazon, and there was something similar within Amazon where there's just a given that you're going to want certain things like distributed tracing or logging at some level when you spin up a new service. And I think what's kind of cool about the idea of StackDriver is if I'm just a startup, then I don't, historically, I don't have the backlog of tooling and infrastructure to be able to roll my own collection of distributed tracing and monitoring and logging tools. But it's nice if I can just get that from the cloud provider out of the box. So can you talk a little bit about the design goals of the StackDriver project? What were you trying to achieve when this project was getting off the ground?
I think we were focused on two things. One is how do we provide integrated observability throughout the software development lifecycle, so operational visibility will not be an afterthought that once you deploy to production, well, I need to monitor that, but rather be something that you can bake into your software, and the signals that are needed for you to maintain your software will be automatically omitted and managed. The other piece was how do we do integrated root cause analysis? Just tracing is not enough because you don't have enough visibility. Logging is way too much data. How do I figure out what's important and what's not? Monitoring provides you the ability to do trending, but okay, now that I figure out something is wrong, how do I go in? So really bringing all those signals together around the construct of services and application, and being able to say the collection of resources, this BigQuery table or this big table or this spanner, together with those set of Kubernetes containers on GKE and this GCS bucket, all together make up my application and be able to visualize that and attach a service level agreement to that. And then when something goes wrong, right click and say, show me what happened when things beginning to go wrong, and have an integrated view across tracing, logging, and monitoring is what our developers at Google learn to expect and what we're trying to provide to our cloud customers.
Let's talk about some specific engineering problems you have to solve when you're building an observability tool like this. Logging, for example, logs, we've done some shows about logging, and logs can get to be a big data problem because logs get generated on a host, and you've got to figure out how often are you going to shuttle those logs from the host to some centralized logging solution. You've got to figure out, are you going to index these logs, or how you're going to index them to make them searchable? How available do you want to make them? How quickly do you want to make them available? How long do you want to keep them around before you garbage collect, yesterday's logs, or the last week of logs? Describe the architecture for the logging side of StackDriver.
I would start by saying that I have the privilege of talking to many of our large customers, enterprises throughout the world every day. And what amazes me is that no two customers are the same. The needs, the way they arrived at where they arrived, the way they think about their business is completely different. And the nice thing about StackDriver is, whether you are cutting edge SRE organization like Snapchat or HSBC, or whether you are more traditional business, you still can get to the same level of log visibility with StackDriver. So from an architectural standpoint, things start with our log collection agent, which is FluentD. It's an open source project with a long set of extensions that let you manipulate the logs as they come into the agent, and being able to deduct logs that are irrelevant, be able to do compression, be able to do things like annotation. And we work with the open source community to enable you to do new and interesting things in the agent every day. Then the FluentD agent speaks to our backend API, which are distributed throughout the world to make sure that, one, we can automatically scale as our customer businesses scale, and second, we can handle any availability scenarios that might happen where an availability zone fails or network connectivity issues happen. And then as the logs get into the backend system, at the backend of Google, we have hundreds of thousands of hosts that deal with the incoming logs and continuously write them to both a backup system as well as in memory to allow immediate querying of the logs as they come in. And one of the key features that our customers love in StackDriver is the ability in our log viewer to say, just stream and show me the flow of the logs as they come in. And when you think about it, that we monitor hundreds of millions of hosts, that's a really powerful thing to do. It's really the equivalent of tail minus F, but on millions of hosts. Then as the logs get older, and you want to do long-term analysis or long-term storage for compliance reasons, StackDriver provides the ability to export those logs and keep them for very, very cheap price on things like GCS buckets, or be able to send them to BigQuery and combine them with other business data in order to do analytics. Or many of our key partners like Splunk or Sumo Logic integrates with StackDriver to PubSub and in real time send the logs that are collected to their specific solution to provide unique experiences through their services.
The FluentD story is interesting. So FluentD is this agent that runs on the customer's infrastructure, that runs on a host and gets configured to do some of the log management or some of the filtering or some of the flagging. We had one show about FluentD a while ago that was pretty interesting, and the guest talked about some of the chains of monitoring or the chains of logging filters and layers of infrastructure that people sometimes set up, where they will collect some logs and send them to a Kafka queue, and then have more processing take place on that Kafka queue, and then shuttle them somewhere else. And I guess depending on the situation, some people want pretty complicated setups where there are different parts of logs getting teed off and into different places. But the general use case is probably figure out some kind of general use case for how people want their logs sent around. I guess you have some sort of defaults that make it at least easy for people to get started with shuttling their logs around.
Yeah, that's a great observation. So I'll throw some interesting things that we hear from our customer. One is, yes, you mentioned the amazing flexibility of FluentD. The second thing is, in StackDriver, as the logs come in, we provide something we call exclusion rules that lets you say, out of the data that is coming in, I can apply filters using regex and say this data I want to see in StackDriver. This data I want to throw away because I don't care about it, even though it was sent in. So it kind of provides both cost control and the ability to reduce the mental load on what you need to analyze. And finally, this data I just want to keep for historical purposes. The second thing that we hear a lot from customers is two features that they love about StackDriver. One is log-based metrics, which is the ability is that as the logs come in, change what you see in the log and create a metric out of that. So for example, tell me what the latencies that I'm seeing for disk reads from all of my VMs across the entire cloud and chart that into a graph. So really turn unstructured data into structured data. The second one is what we call error reporting. Think about, let's say that I'm a big e-commerce vendor and I provide the ability for customers to do shopping on my site. I want to be able to track as I deploy new versions of software, is the number of errors like the 300, 400, 500 that my customer is seeing, are they changing over time and are they changing as I deploy new software? So error reporting automatically extracts error information from logs and give you the ability to do trending and analysis and alerts on the errors within the logs without actually looking through each log entry.
So this kind of product can require a lot of integrations. So you have to keep up with integrations from other cloud providers. You have to integrate with new open source projects. You have to be able to integrate with different host types, whether the user is on some sort of VM or they're on a container within a VM or a container within bare metal infrastructure. How do you structure the team, the StackDriver team, to be able to write the required integrations and to be able to keep up with all of the integrations and at all the different levels of this kind of product?
I tend to think of our integration team as a group of superheroes. There's X-Men, Superman, and really they do the impossible every day. It's a really, really crazy software world out there. But on a serious note, there's two parts for that. One is think of Google Cloud itself. We have over 100 services today and new services getting launched every day. And on day one, customers want those services to be observable, meaning to get logs and metrics for them. So it's both keeping up with all of the amazing innovation within Google Cloud, as well as keeping up with commercial applications like databases, other cloud vendors on-prem. And I can't say that we have a magic formula for that. We're still working on time machines, so we can do 60-hour development a day instead of 24. But until somebody at Google comes up with that, really our core power is the open source ecosystem. Example is our integration with Prometheus, that if you run Kubernetes and you use Prometheus, everything you instrumented with Prometheus automatically go into StackDriver. So it gives us a force multiplier that everything that was ever instrumented with Prometheus suddenly amazingly lights up in StackDriver, and the community empowers us. Another great example there is, you mentioned FluentD and Collectis that have a lot of plugins. OpenCensus today is instrumented in many of the production ready databases. For example, MongoDB, for example, MySQL automatically include OpenCensus instrumentation. So really the only answer I can give here is as Google alone, we can do so much. With the community, we can do so much more.
Azure Container Service simplifies the deployment, management, and operations of Kubernetes. Eliminate the complicated planning and deployment of fully orchestrated, containerized applications with Kubernetes. You can quickly provision clusters to be up and running in no time, while simplifying your monitoring and cluster management through auto upgrades and a built-in operations console. Avoid being locked into any one vendor or resource. You can continue to work with the tools that you already know, such as Helm, and move applications to any Kubernetes deployment. Integrate with your choice of container registry, including Azure Container Registry. Also, quickly and efficiently scale to maximize your resource utilization without having to take your applications offline. Isolate your application from infrastructure failures and transparently scale the underlying infrastructure to meet growing demands, all while increasing the security, reliability, and availability of critical business workloads with Azure. To learn more about Azure Container Service and other Azure services, as well as receive a free ebook by Brendan Burns, go to aka.ms/sedaily. Brendan Burns is the creator of Kubernetes, and his ebook is about some of the distributed systems design lessons that he has learned building Kubernetes. That ebook is available at aka.ms/sedaily. Well, certainly the fact that the agent uses FluentD allows you to leverage some of, stand on the shoulders of a giant that's already been adopted by the community, and you already have some some of the large cardinality of integrations taken care of, probably due to the FluentD leverage there. Getting StackDriver to general availability required you to get it to a place where you felt quite comfortable with all of these, different sets of customers and the different types of infrastructure that StackDriver could potentially be used with, which includes not just Google Cloud, but also other cloud providers, and also I believe on-prem infrastructure as well. If you want to monitor on-prem infrastructure, what was the process of getting it to a place where you felt comfortable with putting it into general availability?
It's been a journey, and we're still on that journey. I'll first to admit that as a Googler, every day customers come to me and say, "Mark, you still haven't done that, and we expect you to do that." And the great thing about observability is it's a never-ending journey. For us, the bar to get to production was for us to say we as Google can trust StackDriver to do monitoring for ourselves. Can it scale to Google scalability? And when we acquired StackDriver, it was a very innovative, ahead of the market solution, but it was a startup. And there's a lot of really, really cool startups there. Every day I see a new company come with new innovation, and it's amazing. The challenge is when you're one of the world's largest, if not the largest, cloud provider in the world, there's a certain level of scale, of availability, of security, of privacy, of establishing trust with our customers that was important for us. And we kept StackDriver in a beta state for a very, very long time. So we can say when we GA'd that we are able to meet the same availability, security, privacy, and scalability requirement that any of our billion user services meets every day. And, it's a journey. There's still much for us to do, but we get feedback from customers every day that for them to run something like StackDriver themselves would have required them to hire 100 people, and that we remove the overhead from them of dealing with stuff that is not core to their business. And that makes me excited every day.
One of the reasons that people listen to this show is to find out about different management structures. And you are a group product manager at Google. What exactly does that role encompass, and what's your interaction with the rest of the StackDriver team?
I think Google is a very unique company. I've been in this industry for almost 30 years. I worked for some of the world's largest companies and had 3 companies that I founded myself. I think Google is the most unique company I've ever worked for. In a way, it's a set of really, really smart people that want to solve really cool problems that can have a positive impact on the world. So, Google does not start from let's build something because we can make a lot of money out of it. It starts with what can we do that will delight our user? Can we do that move technology forward? And we know that if we'll make it right, people will be happy with it. And I think within my team, within the StackDriver team, we have, I think, something like 15 or 16 PMs. Each of them runs their own business. They're responsible for their own customers, and they partner with their engineering team to say, how can I make a difference tomorrow? And, for me as their manager, it's really a learning experience every day. Like every person that joined the team teach me something. And many of the PM on the StackDriver team went on and did really cool other things in Google, in databases, in Google Assistants. And that's the unique thing about Google is that, if you're passionate about making the world better, you can make a difference anywhere.
So you said you've started 3 companies before working at Google?
Yes.
Could you contrast, I mean, this is kind of off topic, but can you contrast your experience starting companies versus working at a big company? I mean, the thing is that the big companies that you can work for today, it's kind of a unique time because there's some really cool stuff going on in the big companies, even relative to the coolest stuff going on at startups. I mean, I guess this has always been the case to some degree, but there's some really cool stuff going on right now. I mean, in both places. But yeah, I mean, maybe if you could just contrast your experience doing 3 different startups with working at Google, like your level of satisfaction and kind of what you get and what you don't get.
I would say I worked in a few big companies before. I won't name names, but corporate has been a very different experience for me than a startup because, in a startup, in my second startup, my business card said janitor. Because honestly, as a startup founder, you do everything, including washing the dishes. In a big company, it's different. People expect you to do one thing and do that well and stay out of everybody else's way and partner with them. Because, it's about moving the Air Force carrier. It's not about the speedboat.
Mm-hmm.
I think what's unique with Google, it's a vast navy of speedboats, each of them, racing towards doing something super exciting. And since all the people in Google are really passionate about what they do, and what amazes me every day is that I sit in a room and I meet people that are so overqualified for what they do and have such an amazing life story. People like Melody McFessel, who's our head of DevOps, or people like Brian Stevens, our CTO, or Eyal Manor, who created the cloud services platform, Hen Goldberg from Kubernetes. Those are amazing people with such a depth of knowledge. And even in places where we disagree, we come and sit in a room and say, okay, tell me where you're coming from. And I've never been in a meeting in Google where the discussion was about ownership or territory or politics. The discussion is always about how can we get to a shared understandings that make both of us successful. And I've never worked in a 80,000 plus company where people are so invested in each other.
Cool. So one thing that I think came out recently from the StackDriver project was this transparent SLIs thing, which is, I think SLI is that service level indicator?
Correct.
Yeah. So service level indicator, this was one of the things that was in the Google SRE book, the different service level components. And the transparent service level indicator, I think this feature is kind of interesting because it's basically if you instrument something in StackDriver, so StackDriver is this cross-cloud, cross-infrastructure platform monitoring system. So if you instrument some piece of your infrastructure with StackDriver, you can get these transparent SLIs, which can actually help you identify, for example, if a cloud product is meeting its guarantees, if it actually is, providing you the number of nines that it claims to. Could you kind of describe the transparent SLI feature? Explain what a transparent SLI is.
I'm really excited to talk about that because for years, ever since the first SRE book came out, and now that we have the second one that talks about practices, customers have been coming to me and say, we love the book. How can we do what you do? And how can you expose to us what you have internally? Like, okay, you sold us on the dream. Now, how do we realize it? And service level indicators, transparent SLI, is really one of our most important milestones towards that. In every cloud vendors that you go to, at least the big ones, they provide you things like, well, if you use their database as a service, then they can tell you how many queries you're running and maybe be able to say, well, how many errors did you see? But each of the services provide some kind of monitoring metric that is unique for that service. What you do not have is the ability to say, since this is a multi-tenant public cloud vendors, how is the service behaving? Is the service provider really providing the service levels that I'm expecting? And when I have a problem, how do I know if it's Google's fault or is it my fault as a customer? Is it my applications that is broken? And with the service level indicators, what we do is we provide a standard set of metrics along the line of the golden SRE signals we talked about earlier, things like error rate, things like latency, and it's the exact same indicator across all of Google Cloud services. Even beyond that, we don't just say, well, here's a service dashboard and our service right now meets its SLO. We say, here's the error rate and the latency for example, Spanner, that we provide specifically for you, the customer, and specifically within this specific project in Google Cloud. So it's not an average of what all our customers are saying, it's the service levels that I'm providing to you right now. And I was really excited last week to be on stage with Ben Trainer, the guys that invented SRE, head of Google 24/7, and a lead SRE from Snapchat, where they demonstrated how they use transparent SLI to very quickly diagnose issues and figure out, is it Google or is it Snap, and make sure that their Snap service remains snappy during the World Cup, which was by far one of the most popular events in the world. And we think that as SREs, we want to automate everything, because when you get humans into observability, things get slower, right? You need to pick up the phone and open a ticket. When you have an indicator that is programmatic, when you can look at the dashboard and say, well, things are going wrong, but the indicators from Google are still green, or things are going wrong and Google indicators are going bad, you immediately know, is it Google? And you can immediately, when you pick up the phone or email Google, you can say, here's the dashboard, and your indicators are saying that something is wrong on your side. So it removes the entire step of troubleshooting and immediately pinpoint the problem, which improves availability to all of our customers.
And so for an example of this transparent SLI thing, so if I was, let's say I'm Snapchat and I'm built on Google Cloud, and maybe Google Cloud Spanner, that the Spanner database is on the critical path for some aspect of my product, maybe I have on my dashboard an SLI for the how long it's taking to get an ACK from the database. When I write to Cloud Spanner, how long does it take to get an ACK back from the database that my write proceeded and my write was accepted to Spanner, and then I could look at that chart, and maybe I'm going to see I've got some high latency right now, and I know just by looking at that SLI that if my service is failing, it's due to Cloud Spanner or not due to Cloud Spanner, just by looking at the dashboard.
Exactly, and we think that that's super powerful because it allows customer to combine their server level indicator with ours and immediately be able to get to the root cause of the issue.
So I was at Google Cloud Next last week myself, and it was my first time there. So I was amazed by two things. One thing, whenever I go to one of these software conferences, I'm always just amazed by how big the software industry is, because you just wind up in conversations with people who are like, oh, you're using cloud? Well, I guess, why not? Of course you are. Like somebody from like a candy company, right? Just long tail customers. But also I talked to some of the people in the vendor booths, and you just, you see vendor booths that are building really big businesses that sound like they're in very niche areas, but because there are so many customers in the cloud, even what sounds like a niche can actually be a pretty good business. So it made me pretty optimistic about the cloud infrastructure business as a whole. That's just among some reflections I had from the conference. Did you have any reflections from being at Google Cloud Next over the last 3 days last week?
I think my main takeaway was wow, to summarize it in 3 characters or less.
It's really big.
Yes, it's, last year we've seen thousands of people. This year we had tens of thousands of people. And the stories, as you mentioned, were amazing, like ranging from, people like HSBC and PayPal came on stage. And, the fact that I had more customers on stage than our executive, the fact that, we had huge partners like Accenture and Rackspace coming on stage and talking about how do they help customer do transformation. Google is known worldwide. Everybody knows who Google is. But to hear the world's largest enterprises and the world's largest partners saying we bet our business on Google, to be honest, it was the proudest time for me as a Googler, because it means that all the hard work and sweat that we're doing, makes a difference. And the other thing is, I looked at all those people with the amazing stories, and as much as the world has been speeding by over the last few years and things have been crazily advancing, I think we're just in the beginning of what we can achieve in the next decade or so.
Mark Carter, thanks for coming on Software Engineering Daily. It's been really great talking to you.
It's been a pleasure, Jeff, always.
GoCD is a continuous delivery tool created by ThoughtWorks. It's open source and free to use, and GoCD has all the features you need for continuous delivery. Model your deployment pipelines without installing any plugins. Use the value stream map to visualize your end-to-end workflow. And if you use Kubernetes, GoCD is a natural fit to add continuous delivery to your project. With GoCD running on Kubernetes, you define your build workflow and let GoCD provision and scale your infrastructure on the fly. GoCD agents use Kubernetes to scale as needed. Check out gocd.org/sedaily and learn about how you can get started. GoCD was built with the learnings of the ThoughtWorks engineering team, who have talked about building the product in previous episodes of Software Engineering Daily, and it's great to see the continued progress on GoCD with the new Kubernetes integrations. You can check it out for yourself at gocd.org/sedaily. And thank you so much to ThoughtWorks for being a longtime sponsor of Software Engineering Daily. We're proud to have ThoughtWorks and GoCD as sponsors of the show.
Wow.